Hello, my name is João Paulo, and I will present the work. It is called Active Methodologies in Incoming Program Class, approved for presentation at conference. I am a professor in the Federal University of Technology, Paraná, UTFPR, Brazil, and we developed this work, a research partnership with professors of IPB, Bragança, Portugal. This study is an approach carried out with students of an undergraduate course in computing on the first day of class in the UTF-PR. Now, let's go to the presentation. This work presents the initial results of a teaching strategy implemented in the algorithm subject of computer science course. The most important information: the strategy was applied on the first day of class. The activity consists: apply active methodologies of teaching and problem-based learning, PBL. 95 registered students participated in the first semester of the course. The activity occurred in the first day of class in groups of 5 students. The proposed activity is based on the initial contents of the subject of algorithms. The contents are listed below, highlighting operational system, memory, storage space, primitive data types, variables, data input and output. This is an elementary content about the universe of computing, which serves as motivation for students. The activity was based in 2 actions. The students answered a questionnaire associating computing elements to daily life routines. It's important to inform that the questionnaire containing 19 questions divided into 4 blocks. Contents worked: variables and data input and output. Even without programming concepts knowledge, develop a smartphone application. The questionnaire was divided into 4 parts to optimize the teaching process. In activities that are too extensive, the student is easily uninterested. Groups answer questions, and at the end of each block, a discussion is held with the whole class. The part 1 of questionnaire, it's composed of 6 questions. The main subject worked is storage space. The image shows the questions made available to the groups. After each group consolidates its answers to each question, the professor conducts a discussion with all groups to consolidate the general understanding of the content covered. This strategy, consolidation of the group, and at the end, consolidation of response with the whole class, is carried out in the 4 parts of the questionnaire. Part 2 of questionnaire, it was composed of 5 questions. It's about RAM, memory, and SSD storage. The 5 questions in part 2 aims to make groups associate the different managed storage available in the smartphone. The part 3 of questionnaire composed of 4 questions. The main subject is discussing primitive data types associating with the available space. The 4 questions in this part aims to make groups associate data types with available storage capacity. part 4 of questionnaire composed of 4 questions. It's about data input and output. The 4 questions in this part aims to make groups associate the elements need to perform data input and output on device. The research problem consists of students' demotivation, and the consequent failure rate in undergraduate courses is associated with factors inside and outside the classroom. The subject of algorithms, emphasis in this work, historically a high failure rate and student dropout. Thus, it is necessary to use teaching strategies that facilitate the learning of content and course success. Among the main factors that influence a meaningful learning stand out the efficiency of the teaching methodology used by the professor, the immaturity of many students when entering higher education, and the previous knowledge brought by the student. The methodology used in this work predominantly qualitative analysis of the problem. For the composition of the documentary corpus was based on questionnaires collected from students. It was applied during two terms, 2019 second and 2020 first. The work was developed in the initial classes of the algorithms course. 95 students participated of strategy, 47 students in 2019 and 48 students in 2020. The overall strategy was centered on two main steps, as shown in the image. Step 1, the groups of students answer the questionnaire that relates the functionalities contained in their smartphones with the functionalities performed of a computer. And step 2, after discussing the questions proposed in the questionnaires, students are encouraged to develop an app for their smartphones. This experiment was based on active teaching and learning methodologies using groups. In this strategy, we used the active problem-based learning, PBL, methodology. We use a real problem based on smartphones. To solve the problem through the creation of working groups with a maximum of 5 students. The problem was to develop a smartphone app which should be installed on their equipment. The development occurred using MIT App Inventor through block program. The professor don't perform any intervention. It was up to the students to find a solution, such as, for example, learning how to use the platform and develop the problem. This is the essence of the active teaching methodology, independent students and the professor in tutoring. The image shows the homepage MIT App Inventor. This image presents the MIT App Inventor screen used for the students to develop the problem. As we can see, the development is accomplished through blocks program. The image shows the code developed by one group, carried out through discussion between members and without professor assistance in the solution. The experience proved to be valid and interesting, according to 1, the involvement level of the students, 2, students' integration in the groups, 3, their motivation in the promoted discussion and the developed applications, And 4, generated additional motivation and dispute in the class. Everyone wanted to have the best app. To verify the understanding of the content worked, an evaluation was carried out with the class using the Moodle platform. There were 13 questions, verifying how they make the relationship between the computation concepts and the problem proposed. As response, we obtained 56 students, 84% of participants scored higher than the university average, and 11 students, 16%, scored close to the average pass. Conclusion with survey applied in the class. Results of applied questionnaire to assess the level of relationship between the concepts present in the challenge and the basic concepts of computing. The strategy used in the classroom obtained positive results. The students were able to relate the concepts with the content necessary for the beginning of the discipline. Most of the class, 84%, scored higher than the average required for approval in the contents worked. The image illustrates 4 apps developed by the groups. Note that each one used a different strategy for design. The PBL methodology establishes that a problem can present several solutions. This was verified for each group as each present different solutions to the same problem and calculator app. The most important, in addition to winning the proposed challenge, all the apps worked on the installed devices. In the end, each group was curious to know how the app of the other groups had become. An interesting fact, some students exchanged the installation files for their app. That was really cool. With this strategy, it was noted that the initial question, will I be able to do it, was changed to I won the challenge. Conclusions. The experiment allowed integration between classmates from the first day of class through formation of groups and discussion about the problem. Understanding the main objective of the research was to get the students to reflect on elementary concepts of computing. To carry out the activity, it was not necessary any previous knowledge about programming. The initial impact and anxiety gave away to motivation for the content work. The strategy used was well received by the class, and the results indicate that it is possible to apply innovative teaching methodology. As future work, we intend the knowledge acquired by each student will be individually evaluated. So it will be possible to verify the involvement of each student in the activity. It is intended to expand cooperation between groups and propose more complex problems in which solutions are complemented between groups. That's all. Thanks for your attention. I'm leaving my email available in case any participant wants to contact later. Thank you very much.